Today I am discussing on polarization. This is very important for examination purpose. So first we have to know what is angle of polarization. If ordinary ray is incident on a refracting surface, then particular angle of incident, this ray becomes plane polarized light. This particular angle is known as IP, that is angle of polarization. It depends on some factors. First one, that is type of refracting surface, and second one, that is light of wavelength. So these two factors that IP depends. So we have to write down the definition. So first we have to write down when a unpolarized light is incident on a refracting surface, then at particular angle of incident, the light becomes plane polarized light. It is denoted by that is IP. It is also called Brewster angle. So here we see that is AO is ordinary ray. At particular angle of incident, the light becomes, that is plane polarized light. This a particular angle is known as, that is angle of polarization. So it depends on first one, that is type of it depends on the type of the refracting surface, type of reflecting surface, and number two, that is the wavelength of light used. So this is the angle of polarization. This is very important for examination purpose. So it depends on the type of refracting surface, and number two, that is the wavelength of light used. And next, that is Brewster law and proof. So it states that the tangent of polarizing angle, tangent of polarizing angle, that is IP, is numerically equal to the refractive index of the medium on which the light is incident. This is the statement of Brewster law. Here we have to, from this, according to Brewster law, that is mu equal to tan IP. We have to prove this. First, SA, that is SA is incident light. SA is incident light. Mu1, that is refractive index of first, mu2, that is refractive index of second. So this is the refractive index of this medium and this is the refractive of this medium. So mu1 and mu2, this is the refractive index. Next, we have to know, that is AB is reflected light. AB is reflected light. So we can write, that is AC is refractive light. So according to principle of the reflection, this is IP and this is also IP, and let us consider this is R. So angle of polarization, that is IP, and angle of refraction, that is R. So we get, that is from diagram B.Sc, that is we know 90 degree, and NA indexed, that is NA indexed, that is 90 degree plus IP plus R. This is 180 degree, so 90 degree plus IP plus R. So we get, that is R equal to 90 degree r equal to 90 degree minus IP. From Snell's law, that is mu equal to P by sine R. We know this is, we can write sine IP, that is sine IP divided by sine 90 degree minus IP. So sine IP cos IP. So 2 by mu 1, that is mu 2 by mu 1. So for air that is mu 1 equal to 1. So mu equal to that is mu 2. So we have written that is mu equal to this. So mu equal to, we get that is tan IP. So this is the Brewster law. So first we have draw a diagram, and with the help of the diagram we can easily calculate, that is the Brewster law proof. We have to remember that is refractive index for air, that is 1, and other medium that is greater than 1. We know refractive index always greater than 1. So this is the theory of Brewster law. So next, that is the another proof, that is reflected and refracted ray are mutually perpendicular to each other. So we have drawn a diagram, and from this diagram this is IP, and we get this is also IP, and this is R. So we have to write down some points. Let a ray of light, that is SA, be incident on a medium of refractive index, that is mu. Refractive index, that is mu. And this is B, AB, that is reflected ray, and this is AC, that is refracted ray. So this is the first introduction. According to Snell's law, we can write that is mu equal to sine IP by sine R. Mu equal to, that is sine IP by sine R. So again we know this is equation number 1, that is mu equal to tan IP from Brewster law, that is sine IP by cos IP. This is equation number 2. So comparing 1 and 2, we get that is sin IP by sin R equal to sin IP by cos IP. This is cos IP. So from this we get this is cos IP. Sin R equal to cos IP. Sin R equal to cos IP. Then we get this is the value. This is sin 90 degree minus this is 90 degree minus IP. 90 degree minus IP. So R plus IP equal to 90 degree. So R plus IP equal to 90 degree. Hence the proof. Next we have to know this is the relation that is mu equal to sin IP by sin R from sense law. Again that is mu equal to sin 90 degree minus R by sin R. So this is cos R by sin R. Again we know that is sin theta c equal to that is 1 by mu. So we can write that is mu equal to 1 by sin theta c. Theta c is the critical angle. Theta c that is critical angle. Theta c that is critical angle. So from this we get that is 1 by sin theta c equal to cos R by sin R. Cos R by sin R. Sin theta c equal to that is tan R. Sin theta c equal to tan R. Tan R equal to sin theta c. R equal to tan inverse. R equal to tan inverse sin theta c. So this is important equation. Then another numericals which is very important for examination purpose. So that is mu is given 1.55 and mu equal to tan IP. So you can write 1.55 tan IP. So we get the value that is IP. Tan inverse 1.55. So we can get the value 57.17 degree. This is the angle of polarizer. So polarizing angle 57.17 degree. We know that is IP. We know that is IP plus R equal to 90 degree. So R equal to 90 degree minus 57.17 degree. So this is R equal to 32.83 degree. I think each and every class will helpful for BSc students. I think all students will gather knowledge from my lecture, and my dear students, I think all students will be benefited by my lectures. Thank you.